Hello guys, welcome to a new video. So it's a 15th day of our 100 days coding challenge, and today's problem of the day is find element occurring once when all other are present thrice. So by the topic we are clear enough what we have to do, but let's see the problem statement as well. Given an array of an integer ARR of a length n, every element appears thrice except for the one which occurs once. Find the element which occurs once. So we are given with an array of length n, and every element in that array appears thrice, but except for the one element which occurs only one time in that array. So let's see the example to get more clarity. In the first example, our n, the length of the array is 4 and the array elements are 1, 10, 1 and 1. So here 1 occurred for 3 times and 10 occurs for 1 time only. So our output will be 10. In the next example, the length is 10 and the array elements are these. If we check 3 occurred only for 1 time in the whole array. Then next we can check 2. 2 occurred in this index and this index as well. So its frequency is 3. 1 also appeared for 3 times in this array, and lastly 34 also appeared 3 times. So only the element 3 occurred once in this array, and thus our output is 3. So by now I hope you got to know what we have to do in this problem exactly. So let's see what will be our approach to this kind of problems. So let's take the first example given in our question. Now the first approach which strikes in our mind, possibly a brute force approach, is to take a hash map, count the number of unique elements in our arrays and map it with their respective frequency in this array. So if we follow that approach and add a unique element in a hash map, our 1 will have the frequency of 3 and our 10 will have frequency of 1, and at last we will iterate through our hash map and check whose frequency is not divisible by 3. So we will get this key and we will return this key. But the problem here is, in the question it is given that the expected time complexity is O of n and expected auxiliary space complexity is O of 1. So we have taken a hash map in this approach. So our space complexity will be O of n, which is not expected. Thus, we have to find another approach to meet our expected time and space complexity. So for that, we can use bit manipulation technique, where we will be doing some operation with the bits of the elements present in our array. So let's see how we will proceed. So the binary representation of 1 is 0001. In the same way, the binary representation of 10 is 1010. Then we got 1 again. So the binary representation is same, and lastly there is 1 present in the array again. So these are the binary representation of all the decimal elements present in our array. And let's mention the indexes. So this is 3, this is bit 2, this is bit 1, and this is 0th bit. So basically the idea is, if the number occurred thrice in the array, the binary representation of the bits will occur 3 times as well. In the same way, if an element occur only once in the array, so the bits in the binary representation will occur only for 1 time. So let's see, as this number 1 occurred 3 times in the array, the binary representation 001 occurred 3 times. We can say that means every bit, that is 1 0 0 0, every bit occurred for 3 times. But in the other hand, the number 10, the binary representation 1010, all the bits occurred for only 1 time only. So if we find out the sum of the bits in a particular index, like if we find the sum of bits of 0th index, then the sum must be divisible by 3 if the element has occurred thrice in the array. I hope it is clear. Let us perform the whole operation to get more clarity. So for the first iteration, the sum of the set bit is 3. In the second iteration, the frequency of bit 1 is only 1. So we will add 1 to our sum. And then in the next iteration, the frequency of 1 is 0. So we will keep the sum 0. And for the last iteration, our sum will be 1 because the frequency of bit 1 is 1. So we got this sum for every particular position of the bits. Now simply we have to check every bits whichever is not divisible by 3, or in our case where the sum mod 3 is not equals to 0, we will be returning that number. So let's check. So in the first iteration we got 3, 3 mod 3 is 0, so we will return 0. So in the next iteration our sum was 1, so 1 mod 3 is not equals to 0, hence we will set it to 1. Again, in the next iteration we got 0, so the mod value is 0, so we will ignore it and set it to 0. And in the last iteration the sum of the frequency of bit 1 is 1, so we will set it to 1. And thus we got a value which is the binary representation of a decimal number 10. Thus we will return this value and we got our final answer. So you can check 10 is the only element which occurs only once in our array. So similarly, you can try run the next example in the same way and you can check whether we are getting the right answer or not. But for now, to make this video crisp and useful, let us jump directly into the code. So at first, let us declare a variable result where we will store our final result. And then to iterate through each bit position and to calculate the sum of each bit positions for every element in the array, we need a loop which will start from 0 and I will be less than 32 and I will increase by 1. We know integers are of 32 bits. That is, it ranges from 0 to 31. So we will iterate through each bit. That is why we have used this loop, and then for each bit position we will calculate the sum. So let's declare it sum equals 0, and then we need a loop to iterate through our given array. For each element it will calculate the number of bits present in the ith index. So for j equals 0, and it will iterate till the last index, and j will be increased by 1 as well. Now we will check whether the bit of jth element in the ith index is 0 or 1. If it is 1, we will increase our sum by 1. So if arr jth index value, we will right shift it by I, and after performing AND operation with 1, if this expression gives 1, that means the current bit for the particular index is 1, and hence we will increase our sum by 1. So by the end of the nested loop, we will be getting the sum of the ith bit for all the elements in our array. And for every ith position, we have to check whether the sum is divisible by 3 or not. So the condition will be if the sum mod 3 is not equals to 0, as we have discussed, we will simply use the OR operation on result and we will left shift 1 by ith times. So we will dry run this part of the code for better understanding, but let us complete the code once. So after performing all the calculations for 32 bits, we will be having our final result and simply we will return our result. So this is all about the code, but before running, let's discuss these two part of the code. So let's understand this with the same example, which was 1, 1, 0, 1 and 1. This was the given example in our question. So by this loop, by the jth loop, we will iterate through every index of our array. That is 1, 10, then 1. And for each iteration, we will right shift our j index value ith times. So when I was equals to 0, we will right shift the jth element for 0th time. So it will be 0, 0, 0, 1. Then we will be performing AND operation of this value with 1. And in AND operation, if either of the bits are 1, then only we will get 1. So here it will be 1 and rest of the bits will be 0. So as a result, we got 1, which is equals to 1, and thus the condition satisfied. So we will increase our sum by 1. In the second iteration, when j is equals to 1, we got 10. So the binary representation of 10 was 1010, and we have to right shift it by ith times. The I is still 0, so there will be no shift. Then thus we will perform AND operation of this binary value with 1. So according to the AND operation, if either of the two bits are 1, we will get 1, else we will get 0. So here all the bits are 0. Hence we got 0 as a value which is not equals to 1, so sum will be not added. In the same way, for these two ones, 1 will be added to the sum, and hence at last our sum will be 3. So we have calculated the sum of bits of ith index, and then we will check whether this sum is divisible by 3 or not. So in our case, 3 mod 3 is equals to 0, so we will not perform this operation. In the next step, when I will be equals to 1, j will be starting from the first index of the array, which is 1, and the binary representation of 1 is 0001. Then we have to right shift it by ith times, that is 1 time. So after right shift, we will get 0, 0, 0, 0. So this index will be shifted once or for ith time, and thus we will get this binary representation. And now we will perform AND operation by 1. So we will get 0, 0, 0, 0, which is not equals to 1, thus sum will be not updated. Similarly, when j is equals to 1, the binary representation of 10 is 1010. If we perform right shift on this, we will get 0101, and thus after performing AND operation on this value, we will get 1000. So here we got 1, and our sum will be increasing by 1. So sum is equals to 1. In the next iteration, that is j equals to 2, we got 1. So 0001, and we will get the same value for all the ones. So finally we will see that the sum is 1 by the end of the iteration. And lastly we will check whether this sum is perfectly divisible by 3 or not. If it is not, first we will left shift 1 by ith times. In our case I is 1. So if we left shift I by 1, what will be our result? So we will get this. So the I is shifted towards left for ith time, and we will perform OR operation with the result. For the first time the result was 0. In the first bit position both are 0, so we will get 0, and then we got a 1 and 0, so it is 1. So this is our updated result. By this we will iterate for each and every bit position, that is for 32 times, and we will calculate our result. And lastly our result will contain the element which occurred for once in our given array, and thus we will return it. So let's get back to the code. So I hope by now the code is very much clear. Let's check if there is any issues. There is a typing mistake. So I think we are good to go with this code. Let's compile and run. So the code is compiling fine. Let's submit our code. So our code has successfully passed all the given test cases, and we have achieved the expected time and space complexity as well. So in the comment section, write the code for the brute force approach which we have discussed in the first part of the video. Let's see who comes up with the correct code. If you find this video helpful, please like, share and subscribe our channel, and let's meet in the next video. Till then, happy coding guys.